The next problem is find the support reaction of beam loaded as shown in the figure. The figure is given as such, where beam is applied with several rods with supports given at B and E. So first you have to identify all the types of supports as well as loadings and mention the variables wherever required at the starting and ending point of the loading as well as where the support is present. So support is present at B and E, which is already mentioned as with the variable, and at A there is a point load, and from point A till C the UDL is acting with the intensity of 4 kN per meter and moment is acting at C. At D there is an inclined 5 kN point load, and from E to F the UVL is acting with the intensity of 2 kN per meter. So all the loads ending and starting point of the loads as well as where the support is applied is given with the variable in the problem itself. So once you have all the variables, drop the verticals from the variable like this and draw the beam, that is AF, mark all the variables B, C, D, E. See, in this beam you have the support at B and E. You can see that EF is a overhanged portion over the support and AB is overhanged portion over the support. So it is a overhanged beam here. Once you have mentioned all the variables, next you start with the writing the distance between the variables. Next, identify the types of loads. Wherever there is a point load, write as it is, as well as moment, write as it is at the point where it is applied. So I have a point load here at E, write as it is, traveling downwards with a value of 3 kN. So the arrow mark is like this. And there is a moment at C, write as it is, that is anti-clockwise 2 kN meter is acting at C. Next, you can see that at D there is an inclined point load which has to be converted as a vertical component and horizontal component. So the vertical component will be downwards 5 sine 30 and horizontal component will be towards negative x-axis 5 cos 30. So these are the point loads, moments and inclined point load which you need to write as it is at the points with the conversions. Next, there is a UDL here. The UDL starts from A and C. So where UDL can be taken of intensity 4 kN per meter for a stretch of AB once and again for a stretch of BC another time. So that means there will be one point load because of this UDL of stretch 1 meter which will be acting at middle of 1 meter, that is 0.5 from either the point A and B. Again coming for the stretch, BC is having a UDL of same intensity 4 kN per meter of length 2 meter which will be acting at the middle, that is 1 meter apart from B and C respectively. Or else it can be converted into one single point load where the entire UDL is taken with the intensity of 4 kN from point E till point C of length 1 plus 2 meter, that is 3 meter, which will be acting as a point load between A and C at a equal distance of 1.5 and 1.5 from point A and C respectively. But in this problem I'll convert the UDL in such a way that I'll take the UDL for once for the stretch AB, another time for the stretch BC. So I'll convert UDL of a stretch AB of intensity 4 kilonewton per meter, length is 1 meter. So a point load will be acting at the middle of 1 meter, that is 0.5 and 0.5 from either the point, that is A and B, with the intensity. So the intensity here will be area of the rectangle, that is 4 kilonewton meter, height into breadth. Breadth is 1 meter. Meter and meter get cancels. So total of 4 kilonewton is acting at the middle of AB. Next, coming for this stretch of UDL, BC is of length 2 meter, where UDL intensity is the same UDL intensity, so it will be intensity of point load will be area of the rectangle, that is again the intensity, again the height is 4 kilonewton per meter, and now the length is 2 meter, so it will be 2 meter into 2 meter here. Meter and meter get cancels. So total of one point load of intensity 8 kilonewton is acting at the middle of 2 meter, that means 1 meter and 1 meter apart from point B and C respectively. The moment is written as it is here, then inclined forces are converted, and UVL has to be converted in such a way that you know that the centroid is towards the 90-degree angle, that is towards E. So somewhere at this point, the point load of the UVL will be acting with the intensity, that is area of the triangle. Half into base is 1 meter into height is maximum height, that is 2 kilonewton per meter. Meter and meter get cancels, 2 and 2 get cancelled, so the intensity of point load will be 1 kilonewton here. So this 1 kilonewton will be acting, where this distance will be 1 by 3 of 1 meter, that is the base of the UVL, and this distance will be 2 by 3 of 1 meter from E and F respectively. Next we go for the supports. At B there is a roller support, so there will be upward one reaction, that I'll take it as AB. That I'll take it as RB. Next at E there is hinge support, which will be having two reactions. One I'll take it as REY, another I'll take it as horizontal REX. So assumption for REX, I'll take it as towards the positive x-axis. So we'll see whether the assumption is correct or not. So now I have converted the space diagram into free body diagram by converting all the supports as well as loading into magnitude and direction of a force. Next we apply the condition of equilibrium, starting with sigma h is equal to 0. Collect all the forces that is traveling in horizontal manner. So in the figure, as you can see, this phi cos 30 is towards negative x-axis, and REX we have assumed it as towards positive x-axis. So the equation will be minus phi cos 30 plus REX is equal to 0. So therefore REX is equal to plus phi cos 30, that 4.33 kilonewton, which will give one of the reaction, that is REX. Next you apply sigma V is equal to 0. Collect all the vertical forces including the reactions. Starting at a point A, there is one downward 3 kilonewton minus 3. Between AB there is one downward 4 kilonewton minus 4. And at B there is a upward reaction RB that will be positive. So plus RB. Between B and C, there is a downward 8 kilonewton minus 8. At C, there is a moment. So, for the equation sigma V, you will not get this moment into the consideration. So, go for the point D, where there is a vertical downward force, that is minus 5 sine 30, and you need not consider sorry, 5 cos 30, since it is a horizontal, which is already taken here. Next, you go for point E. There is a vertical upward reaction plus REY, and you need not take again REXY because it is already taken in sigma H equation. Next, you go for the load which is traveling downwards, that is minus 1 between E and F, which is equal to 0. Solving this equation, you will get a equation RB plus RE y is equal to 18.50 kilonewton. Next, we apply for the third equation, that is sigma m is equal to 0. While applying this one, you have to apply either any one of the point of support. So support is present at B and E. So you consider either B or E. So I'll consider the B as a point. So I'll apply sigma MB is equal to 0. So you start either from point F or you start either from point E. So I'll start from point E. So point of consideration to find out the moment is this point. So you have to find out the perpendicular distance to this point. So while taking the moment, you be careful. At the point E, there is a force of 3 kilonewton. The force is 3 kilonewton. A perpendicular distance. The point is here. Line of action will be like this. So you have to drop a perpendicular from this point to the line of action. So this will be the perpendicular distance, that is nothing but 1 meter. So into 1 meter, and it will be acting or rotating to point B in this manner, that is anti-clockwise manner. So it is minus 3 into 1. Next, you come for the force that is present in between AB, which is again downward force 4 kilonewton with the perpendicular distance. Point is here, line of action is this, drop a perpendicular, so this will be the perpendicular distance, that is nothing but 0.5. So into 0.5, again it will be acting, since arrow mark is downward, it will be acting in anti-clockwise manner to point B. So it is minus. Next, you go for point B. There is a force here, but it is passing over to the point B, which will create moment equal to 0, since perpendicular distance is 0. So you need not consider RB, or the equation is nothing but equal to 0. Next, you go for the load present here, 8 kilonewton, that is downwards. It is acting downwards with the intensity 8 kilonewton and a perpendicular distance. Imagine the line of action is like this. Point to be considered is this one. From this point, drop the perpendicular. So this will be the perpendicular distance, which is equal to 1 meter. So the perpendicular distance is 1 meter. Next, this is downwards. For B, it will twist in this manner or rotate in this manner. So it is now clockwise. So it will be positive 8 into 1. Next, you go for this moment. Now, since we are finding the moment, all the forces will create a moment when it is multiplied with its own magnitude with the perpendicular distance. See, this moment is already converted in that format and given. So do not leave this moment. You have to consider this moment with the effect. Now this is having an arrow mark in such a way that it is effective in anti-clockwise manner. So it is minus 2 kilonewton meter. You can see that I'm not writing any unit here. So every value is now kilonewton meter. This is kilonewton into meter. So this whole term is kilonewton meter. This whole term is also kilonewton meter. This is kilonewton meter, and this is again in the figure directly given as kilonewton meter. Next, you go for point D. First, consider the 5 sine 30 force, whose line of action is like this. Point is here. From here to here, drop a perpendicular, which will be the perpendicular of distance 2 plus 2, that is 4 meter. So force is 5 sine 30 into perpendicular distance is 4, and it is the arrow mark is downward, which will be again acting in clockwise direction. So it is positive 5 sine 30 into 4. Next, there is a horizontal force here, 5 cos 30 acting. You can say the line of action of this force is passing through the point B. So it doesn't create any. Next, you go for point E. There is two reaction. Rex, again it is passing through the point B, so no moment. Rey is vertical force, which is acting upwards. So the value we don't know. The magnitude is Rey into perpendicular distance. Line of action is like this. Point is here. Drop a perpendicular. So it is a distance of 2 plus 2 plus 2, that is 6 meter. With what kind of effect? Now the arrow mark is upward, so it will be acting in anti-clockwise manner to point B. So it is minus. Next, one more force, that is 1 kilonewton acting downwards. Imagine the line of action here. Point is here. From here to here you have to drop a perpendicular. So the distance here is 2 plus 2 plus 2 plus 1 by 3 into 1 meter will be the perpendicular distance. And the magnitude is 1 kilonewton. So it is 1 kilonewton into 6 plus 1 by 3 into 1 meter. So this will be the magnitude of moment created by 1 kilonewton, and it is now downwards, so it will create a clockwise effect. So it is positive, which will be this entire equation should be equal to 0 when it is in equilibrium. So by calculating this equation, since there is only one unknown here, that is Rey, 2.89 kilonewton. Next, by this equation, or you can consider this as equation number 1. By the equation number 1, you have Rex now, so substitute and find out what is Rb. So it is 18.5 minus 2.89 kilonewton, 15.612 kilonewton. You can check these two values, Rb and Rey, by changing the sigma mb condition for another point, that is another point where there is a support. You can apply for sigma mb at E and apply same equation and check out the values of Rb and Rey.